Good afternoon. So in the previous lecture, we have studied about basic concept of any chopper. How chopper converts a DC voltage from one level to different levels of the DC voltage. As I told you, the transformer is used in the AC system for conversion of voltage levels from one level to different levels. In the similar way, in the DC voltage, we used chopper to convert the level of voltage from low level to high level or high level to low level. On the basis of the voltage, we convert in the either we convert from low to high or we convert from high to low. We use two types of chopper. First one is step down chopper, in which we reduce the voltage level. Second one is step up chopper, in which we increase the voltage level. So previous class we have already studied step down chopper. In this class we will study step up chopper. Step up chopper, the circuit diagram of the step up chopper is given here. The position of the switch is interchanged. In the place of inductor, in the previous case, inductor was not present, but in this step up chopper, the inductor is also present in the circuit. The position of freewheeling diode is also changed in the step up chopper. Therefore, now we will study one by one. When switch is closed, when switch is open, what will be the output voltage. So first case, when switch is on, when the switch is on, the short circuit of the it will short circuit the load. Hence output voltage during the T on is 0. When T on is 0, the switch is on, it will short circuit the output voltage. So at this time V naught will be 0 volt. During this period, inductor gets charged and Bs becomes Bl. The whole voltage drop across the inductor, so inductor is charged at Bl is equal to Bs. Where delta I is the peak to peak inductor current. We can now we will represent by the mathematical expression. B naught is equal to we can express B naught is equal to 0 and Bl is equal to Bs. These are two conditions occur when switch is closed. We can represent VL is equal to L di by dt is equal to Bs. That is VL is equal to Bs. So we can represent VL is equal to L di by dt. As we know, in voltage across an inductor is represented as L di by dt. We can represent di is equal to delta I and dt is equal to T on equal to Bs. So rearrange the terms and we can compute delta I from here is equal to, that is delta I is equal to Bs upon L into T on. In the second case, when switch is off, the L discharge through the load, we will get summation of both voltage Vs and inductor voltage Vl as output voltage. In the second case, when switch is open, this switch is open. Now, this inductor will discharge through this load. At that time, the load voltage V naught will be sum of the Bl plus Bs, that is represented here. Actually, we have to compute the value of delta I from this expression again. B naught is equal to Bs plus Bl. Then VL will be V naught minus Bs. Rearrange this term, and VL is equal to, we can again represent VL is equal to L di by dt is equal to V naught by Bs. Again we compute represent di by delta I and dt by T of into L, and rearrange the term. You can compute T of delta I is equal to V naught minus Bs upon L into T of. We will rearrange the term and we get this expression. The second condition, when the switch is open, then inductor, the circuit diagram of the second condition is this: switch is open, now B naught will be Bs plus Bl, and rearrange the term Bl, B will be compute L di by dt equal to B naught minus Bs. So by rearranging the previous terms, we can get this expression. Now delta I of during the on times and delta I during off times. You get these two expression. Expression number 3 and expression 4. You get these two expression. Equation number 3 and equation 4. Delta I become equal, and rearrange the term. When we rearrange the term, we see that ds by t1 is equal to this. Now L become L cancel out, L cancel out, and bs is equal to t on plus t of b naught t off. So final expression of b naught will compute like this. B naught will be b naught bs upon t of plus into multiplied by the t time, t is equal to total time period is equal to t on plus t off. So total time period represented by the sum of the two time, t on plus t off. Again divided by the t, both numerator and denominator, we will get this expression b naught. Again t on by t is duty cycle, as I told you. T on by t total t is equal to duty cycle. So represent here t on by t is to d. So we will get this expression. Therefore b naught is equal to v1 minus d. We can, as we know, t on from 0 to t on can value from 0 to t. So d will be always less than 0, d less than 1. When d will be always less than 1, so 1 minus less than 1, something will less than 1. So b naught will be divided by this any number which is less than 1 will increase the value of b naught. So we can get increase the value of b naught by this expression. Suppose duty cycle is 50%, d equal to 0.5 50%. So b naught will be bs upon 1 minus 0.5 0.5 divide 0.5 is when we divide by 0.5, it becomes twice of b naught. So b naught will be twice of bs when there is a duty cycle is 50%. Buck boost converter or step up down chopper. Previously in two topics we have studied, first step down chopper, then we studied step up chopper. Now how can we use one circuit as a both step down and step up circuit. In the previous case, you see the circuit diagram. The position of inductor is here and switch is here and diode is here. In the step up down chopper, buck boost converter, the position of switch and inductor is interchanged and polarity of diode is also interchanged. You can see here. Similarly for all in the previous two cases, study of the buck boost converter is also remains same. First we compute the delta I for t on, then we compute delta I for t off, and you get these two equations, we compute b naught value. This is buck boost converter step down chopper. With the help of buck boost converter, we can increase or decrease the input voltage as our output side in our requirement. When the switch is on, first condition, when switch is on, you can see here this. When the switch is on, there will be applied across inductor, voltage will applied across inductor. Switch is on, so voltage will applied across inductor, because diode will be act as open circuit, because it's reverse bias, so it will act as open circuit and inductor will charge. So BL will be Bs, because all the voltage will drop across the inductor. Again we represent BL is equal to L di by dt is equal to Bs, and we compute delta I is equal to Bs upon L into T on. We again divide by you can see in this expression we divide by T on by T and multiply by the T. Final expression we get like this. We multiply by T on by T and divide by T. We will get this expression. Again you can see T can be represented by T is equal to 1 by F, because time period is inversely proportional to frequency. So we get final expression of this. Final expression of this expression, delta I is equal to d bs d on by t, so d bs upon lf. Second case, in the second case, now chopper is off. Inductor will be now discharged, reverse the polarity and discharge through the load. Now inductor will discharge through this load. During the discharge, B naught is equal to minus of BL, because inductor voltage now drop across the load. And again we represent BL is to L di by dt minus B naught. And again represent delta I by di by delta I and dt by t off into L. Again we rearrange the term, we will get delta I is equal to this expression, B naught by L into t off. Rearrange this term. Now you evaluate, you put again equation 4, equation 6 and equation 5. Equation 6, this is equation 6, and equation 5, this equation 5. So we will put we liquid these two equations, and we can see expression, and we compute B naught value. Now B naught will be dbs, we put fl in multiply by at this side, ll will cancel out and multiply by this side, then we compute B naught will be, we rearrange the term, and we finally we get B naught equal to this expression. It is very simple, just rearrange the term, you will get like this, when d is t on by t. Now let's suppose d can be varied from 0 to 1. When d will be 0 to 0.5, it act as a d 0 to 0.5, it act as a, when d is 0.5, when d is 0, then 0, when d is 0.5, b is b, when d is 1, when b will be, b not will be infinity. So from 0 to 0.5, output voltage varies from 0 to Vs. Output from d value 0 to 0.5, d 0 to 0.5, duty cycle means duty cycle on time of the switch is 0 to 0.5, it acts as a step down chopper. When d 0.5 to 1, the step voltage will varies from the Bs to less than infinity. V naught will be greater than Bs, less than infinity. Act as a step up chopper or boost operation. Buck operation means reduce the voltage, boost means increase the voltage. So on the value of duty cycle, if it is less than, greater than 0, less than 0.5, it will act as a step down chopper or buck converter. If d is greater than 0.5 and less than 1, it acts as a step up chopper. So this is all about chopper. We study step down chopper, we study step up chopper, and we study step down step up chopper, called as buck boost converter. Thank you.